So we're looking at this question, build array from permutation. And the question is, given a zero-based permutation nums, zero indexed, build an array answer of the same length where answer I is equal to nums I, where each zero is less than equal to I, that is less than nums.length, and return it. A zero-based permutation nums is an array of distinct integers from 0 to nums.length minus 1 inclusive. And here we have the input, that is nums list 0 to 1534, and then the output would be 0 1 2 4 5 3. And the way it's working is that we have the same list that we have right here, and we have for each index we use the value or the element as a new index so we can get the final value. So for example, we have nums 0 at index 0, we have the value that's 0, which is this. And then we would use the nums list again, and now the value that we got from there, we would use that as a new index, and we would get the final value that's 0. Then at nums1, we have the value of 2. Now we would use this value as a new index, so we would have nums2. So at nums2, which is 0 1 2, this right here, we would have the value of 1, so this would be our final value, that's 1. At nums2, we have at index 2 we have the value of 1, which is 0 1 and 2, so we have 1 right here. Now we would use this value as a new index, so we have nums1, which is 2, which is this right here. At nums3, we have the value of 5, which is 0 1 2 and 3. So here we have the value of 5. Now we would use this as a new index. So we would have nums5, and at index 5 we would have the value of 4. So we will go towards index 5. So this is 0 1 2 3 4 and 5. So at index 5 we have the value of 4. Now we have index 4. At index 4 we have the value of 3, which is this. Now we would use this as a new index. So we have nums3, that would give us 5, which is this right here. And then we have index 5, which gives us the value of 4. Now we would use this as a new index. So when we use this as a new index, we have 0 1 2 3 4. So here we have the value, the final value would be 3. And the way we would do this, so first thing we would do is we would initialize and declare our answer variable, and they have in a way pretty much like done most of the work right here, where they say answer I is equal to nums I. So we will use for I in range. The reason we would use I is because we want to know what the index is, and then we will do for I in range length nums, and then here we will get the value, and then we will do nums I. Now this nums I right here, what this pretty much is doing is it's doing the same thing as this right here, and this portion right here nums I, it would be the portion that we have on the left section at the left side. So nums I would give us these indexes 0 1 2 3 4 and 5, and then we would use that index value, that value as a new index. So you can see that how this would get replaced, and we would have 0 2 1 5 3 and 4. And the portion that we have, this portion right here, this portion would be the outer section, and then we would just return answer, and we will run this. Oh, actually we have to do answer dot append, because we're not appending anything, we're just traversing through it, so of course this would be empty. So we will run this and submit, and there we have it. And in terms of time complexity and time complexity and space complexity, we are looking at ON. The reason we are looking at ON is because we are only storing as many elements as there are in nums. So that's why we have ON for space complexity, and for time complexity, we are also looking at ON because we're not doing any sort of like strange computation. We're just traversing through the list, and then we get each element, and then we get the value at each index, and then we store that, whatever the final value that we get, and then we append that inside that, uh, and that's about it.